start from introducing the jury members. My name is Yewang Qi from Donghua University, and Professor Luo Fangyu from Taiwan Normal University, Professor Zhou Huijun from Nanjing University, and Professor Wang Yinong from Nanjing University. Okay, so I think we should decide, or have we decided which one to be team A, team B? Have we done this yet? No. No? Then we should decide. Okay, how are you going to decide? Agree? Agree? Okay. You get to choose. You choose to be team A.
Yeah, I choose to be team B.
Okay. Team A would be Nanjing Normal University, and team B is Nankai. Team C is Sengong University. Okay. So do we need to introduce your team members? Yeah, we should. Okay. A quick introduction of your team members, please.
Okay, let me introduce my team. And I'm the captain, and this is my teammate Shikai, Jiao Wenjing, Lin Shuchong, and Duan Jingze.
Good afternoon, my friend. We are from Nankai University. My name is Tang Yugan. This is Zhang Xinjian. This is Wang Keyu. This is Xin Huiyan. And I hope we can have a pleasant discussion. Thank you.
Good day, everyone. I'm Chen Yixing from National Sengong University, and this is my debate.
My name is Gong Wanxuan.
I am Zhang Banghan from NCG.
I'm Xu Zhu.
Thank you for having us.
Okay. This is Sunday. Okay. So I guess we should start the report. So each team will take turn in order of A, B, C. You have 10 minutes of reporting. And we start from Team A. Ready? We start.
Good afternoon. Let's talk about Fast. Is a kind of device consisting of wooden blocks and thread like this. And here's some keywords. First, wooden blocks, inclined thread, that are details of the device. And second, faster. We are supposed to figure out how to define or compare fast. And third, explain how affect, which means we should find relevant parameters and how they affect motion. And so next, let's define fast. Here, look at the figure. The fast chain with a dropped onto a surface and the free chain without a surface. We define a final speed, that is the speed at the moment just before the last clearance. That is the highest one of fast chain collide with the table. And so we define a delta V final, that is the final speed of fast chain minus the final speed of free chain, like this equation. And then we can focus on problem. And here's our table of contents. So next is model construction. To simplify the problem, we need approximation and assumption. And we assume that it as completely inelastic clearance. Because in the experiment, we can see the response is slight. So we make this assumption, and we ignore the moment of gravity, because when clearing, the gravity is far less than the impact force. And then we ignore the mass and elasticity of the thread to simplify the calculation. And here's the process motion. We can divide it into 3 steps. Free fall, clearing at a point and revolve around a point. Then the next block. Just like this picture. And the capital letter N means the whole block numbers, and the small letter n is changing, representing the order from the bottom up. Like n equals 1, then free fall, clearing, revolve, and then curriculum. And until the n equals the capital letter N, and it will stop. So next is theoretical derivation. In general, fast chain is a kind of connector. Yes, so we discussed a simple connector to learn about its principle. Here, free fall of an ordinary thread onto a surface. We can divide it into 3 parts. The yellow part is free fall, and the light blue means salutation, which means the speed suddenly turns to 0. And here, dark blue, that is static. And let's focus on the yellow part. There exists gravity and the normal force. Here, the normal force. If the normal force equals 0, then the accelerated speed A equals the acceleration of gravity G. And in fast chain, here, if the normal force is greater than 0, then the A is greater than G. So we can give a qualitative analysis. We have 2 views. First is dynamics. Here, point Q hits the surface, and then block PQ revolves around Q. And block PQ's applied turn to the thread applied turn to block MN. So here, the point M, accelerated of M is greater than G. And from the view of energy, it's obvious that there is energy loss due to clearing, but it still goes faster. The reason is energy transmits from lower to upper blocks. So the upper blocks speed up, but lower blocks do not. And as to qualitative analysis, we divide the whole process into many steps. Step 1 is free fall, and energy is conserved, so we have this equation. And step 2 is the clearing. Angular momentum is conserved at point Q after and before clearing. And here, we give a clear, it's shown clearly in the figure of angular momentum, and here's a revolution here. The next step is PQ revolves around Q. Energy is conserved when rotating, and here we regard the upper n-1 blocks as a whole. And step 4 is iteration. So for a certain n, to simplify calculation, we define a GFN and a FFN with iteration. We can get result of first block, then the upper one. And we have defined the final speed before, just like this, the final speed, just like this. This process is final speed. And so step 5 is the final block free fall. And then the whole process is finished. We can see the relevant parameters here, those 5. Here they are. Block number N, initial height H, thread length A, angle theta, block length L. So let's give a simulation. Block number N. The block number N represents the times of clearing. Each time of clearing means the thread will pulse block and it will make speed up. And about initial height H. If H increases, the time of free fall increases, and the speed before clearing increases. So there will be a bigger jump of speed, and finally it's faster. And about thread length A, if A increases, indeed the time of free fall increases. So it will be faster, like the last parameter, but it's not obvious. And about block length L, if L increases after clearing, there will be a omega multiply L, which is the jump of the speed will be bigger and it will be faster. And about angle theta, if theta increases, the V cosine theta decreases and it would be slower within this range. And about experimental design, we use blocks, 3 kinds of rope and glue wire. Here a device to release, like this. We just want to make sure it will be released at the same time, the 2 chains. And to do pre-experiment with different chains. And indeed, we find some problems in different chains, like easy to be out of shape or waggle, so we have made some changes. Here's the final draft with glue and the jewelry thread. And here's a list of data. So next is our experimental proof. In experiment, we found error, like this. This figure, about 5 parameters. And so we need to correct our theory. We assume there isn't energy loss in clearance. Indeed, it has. So we assume energy loss in clearance each time delta E is in direct proportion to total energy E. So we can give speed a correction like this. And after correcting, we can get a better result about block number N, about angle theta, and about initial height H, and about thread length A, block length L. So finally, we will give an error analysis. We ignore the speed component omega L sine theta, and we assume elasticity coefficient K equals 0, and about different material and unavoidable energy loss. So we can give a summary reflection. The core of our theory is energy transmits from lower to upper blocks and upper block speed up. And the block number N is in direct proportion to speed, which means if N is bigger, the chain will be faster. Also, thread length A, initial heat H, and block length L is in direct proportion, while the angle theta is in inverse proportion. And here's our reference. And thank you.
I'm ready. Hello everyone, my name is Tang Yudan. I'm come from Nankai University. Today I will have a report about the problem number 6, the fast chain, and I hope we can have a pleasant discussion. Thank you. The first, let's have a review to our problem. We use some wooden blocks and 2 threads to make a chain like the figure shows, and for such figure, we make it have a collision with the horizontal surface, and compared to the free fall, it will be faster. So the problem needs us to do 2 things. The first, we need to explain why it be faster than the free fall. And the second, we need to investigate the parameters, how to influence the chain's motion. So we just get the 2 problems to get our research. These are our contents. We will have a report by this author. Oh, I'm sorry, I think this must be just white. I'm sorry, it's just maybe the problem. Yeah. And let's get on our first part, the pre-experiment. We use 2 same chains and make them fall in the same time. One of them make it fall onto a horizontal surface, and another just keep free fall. And we can see our experimental results that the chain which fall onto a horizontal surface will be faster than the free fall. We can see the results. Just say it. Yes. And so we have analyzed to its velocity, to its time, and we can find that when the time increase and the velocity get faster and faster, and we can say its acceleration will get faster. And so we must have a more detailed analysis. And let's get on our second part, the serial analysis. And let's consider why, and let's consider its physical senses. Yeah, it's just why it will be faster than freeform. Let's consider a single collision process. We just say the last block, and we can find that when it have a collision with the surface will give it an impulse. And because of impulse, it will give a torque to the center of the last block. And because of torque, the block will rotate, and so that the right thread will act by a tension force. And because of tension force, it will make the above block act by a bigger force than gravity. So its acceleration will be bigger than the gravitational acceleration. Yeah, this is why it will be faster. And then let's consider the whole transform. And these are our parameters: the block's mass, the length, the tilt angle, the number and the distance between two holes, and the landing speed. And let's consider mean according to the principle of angular momentum. We can write down 4 equations, and by these 4 equations we can get the solutions, and we can find the V2 is after collision, the velocity of the above block's velocity, and the V1 is the after collision, the last block's velocity. And if we need our chain get faster, we need the omega 2 is bigger than 0. So it means that our theta is smaller than a theta 0. The theta 0, we can have a serial analysis. We can find that we choose x is equal to half of L, and we can get the theta 0 is 50.7 degrees. And we define a speed up ratio, the lambda, the V1 and V2 and V0's ratio, so that we can have a clear description of its fast. And then we have a simulation to the lambda. We change the theta, and we can find that with the theta increase and the lambda increase. So the smaller the tilt angle, the larger the speed up ratio. And when we change the number of the blocks, and we can find that the less number of the blocks and the greater the speed up ratio. And when we change the distance between the two holes, the distance, the x, and we change the distance between the two holes, and we can find that when we get the bigger x, and we can find that the acceleration will get bigger, and the speed up ratio get bigger. And for the same length, and the x is closer to the half of L, and the greater the speed up ratio. And these are our assumptions. These are our motor assumptions. We just use this assumption. We can, similar to each collision, we can using the ice lambda. We can describe the ice velocity. And by the lambda ice, we can just write down the I and 1's velocity and our I1 and 2's velocity. And so we can just write the I and 1's velocity. By this formula, we can find that the lambda is caused by the collision, and the right part is caused by the free fall. And by this formula, we can just make iteration so that we can get our zero date, and we can get our velocities. Formula is by this formula. We can find that our velocity will influenced by tilt angle and the distance between two hills, and the length of the block, and the distance between two blocks, and the number of the blocks, and the restoration factor. And so let's get on our experiment. We need to have some important parameters experiment. These are our chains, and we use hot melt gun to collect the block and the thread. We use fashion thread because it can waste less energy, so that we can make our chain get faster. And then these are our data. We use some C++ to have a simulate, so that we can have a serial data, and we use tracker to point the top block centered, so that we can get its velocity over to its times figure. And then these are our way to get its acceleration. because there have too many points, so that we need to have a way to make it have less error. So that we choose every point 1 second to take a slope, so that we can get a 6 acceleration. Yeah, and by the acceleration, we can get the whole chance falling. We can find that the red line is the 0. We use acceleration and get the 0 dead. And we can find the black point is our experiment point. We can find the acceleration will get bigger and bigger. And we can find our 0 is some fit to our experiment. And then when we change the stick's length, we can find that when the length of the block get bigger, get longer, and the acceleration will get smaller. So that we think the shorter of the block and the greater the speed, the acceleration effect. And when we change the tilt angle, we can find that we use our 0, we can find with the theta increase, our acceleration will decrease. But to our experiment, we can find the black point, we can find that with the theta increase, the acceleration will first increase and then decrease. So this is why, because in our 0 assumption, we just ignore the collisions time. So if we think the collision time is short, but if we add the collision time, we can just have a fixed to our 0. We can get the right 0 car. And then we change the sticks number. We can find that the point is 24 sticks and the red is 12 sticks. We can find that when we choose the smaller number of sticks, its acceleration effect will get bigger. And when we change the distance between two holes, we can find that when for the same length of the block, the x is the distance between the two holes is closer to the length of the block, and the acceleration will get bigger and get faster. Yeah, and then let's get on our conclusions. The first, we just explain why the fast chain will be faster than the freefall. And then we just study the number of sticks, the length of sticks, the distance between holes, the chain's tilt angle, and other related parameters. And we can get our conclusions. The number of the stick gets smaller and the acceleration effect will get bigger. And the length of the block gets smaller and the acceleration effect will get bigger. And the distance between two holes gets closer to the length of the block and the acceleration effect will get bigger. And to the tilt angle, when the tilt angle increase, the acceleration first increase and then decrease. It will reach the maximum at about 20 degrees. And that's all, and these are our reference. Thank you so much.
Now move on to Team C.
Can you hear me? I'm not good with microphones. Sorry, my hand is shaking.
Excuse me.
Due to time constraint, we have a lot of things to say, so I will omit a lot of things. And we are One Angel from National成功 University, and today we will bring to you the problem fast chain. Fast chain, the system right here, both of these fast chain, but then this is the one that colliding with the surface, and this is free falling. So as you can see, when it collides with the surface, it produces a torque which pulls the block on top of it downward, and thus it produces a slight delta V, which is acceleration. And the increase in time, the decrease in the time taken is very slightly. But this is that. So basically, the collision causes torque, angular momentum, and this angular velocity will cause a pulling down motion of the block because the block on top has lower velocity than the rotation motion. And then this motion will cause the acceleration, and then this acceleration we approximate it into a constant acceleration over time k times delta t. Delta t is actually the time in the varying acceleration, but then since we approximate it, the time will be longer, times k. And then using this model, we use a formula based on this simple model. It's just an estimate, it's not based on any formula at all, just estimation. So experiment, we take videos with camera 1200 frames per second and then analyze the tracker. And then these are material used. And we design such that the longer side will have the same length no matter what angle. And changing the length on the shorter side, we can change angle of the block. And this is our experimental data. Delta V over V with the angle of collision. So different angle of collision will cause different increase in velocity. And this all point is obtained by tracker. Now you see that high angle has negative delta V over V, meaning deceleration. This we call it slow chain, attributed to slow chain phenomenon, where at high angle, the block pull the block upward or collide with it, causing the chain to have a deceleration. We'll talk more about this later on. And then compare the data we have to the formula we use with these constants. We find that it fits the model quite nicely. So we can use the model to approximate our actual thing. And then we say delta V over V is a function of theta and it's not a function of velocity. We use different velocity to do the same experiment again, and we find it fits quite nicely. And since it is not a function of V, we can rule out error resistance. And there's a special case here when the velocity is 0. There is a little contribution to delta V because the rotation motion has little velocity compared to the falling down of the block. So there will be no pulling down. The length of string, if they're similar, they produce almost the same delta V over V, but then the shorter one will produce more. And then we see that there is 3 lines here, 3 distinct lines. And this 3 distinct lines, we can say it is produced by the edge surface problem. What do you mean by this? The surface of the edge colliding with the surface of the block is not straight. It can be have an angle shifting or like that. So it will produce 3 different types of velocity. And we say these 3 kind of velocity will produce these 3 different lines. And then we can see for the same angle and the same height, we can see that this block here will travel faster and this is slower, slightly faster. You can see this in tracker, but then not with naked eye. I'm sorry, but it's that. What is actually delta V over V? So if you know delta V over V is a function of theta, given the theta, you can find delta V over V. And then if we know delta V, you can find the final velocity of a collision. So for example, if the angle is 20, so from this graph we say the delta V over V at 20 degrees is 0.09. So if you say the initial velocity is 2 meters per second, the final velocity will be 2.18 meters per second. So we are not interested in one collision, we are interested in multiple collision, the whole chain itself. So we find the time taken of the fast chain compared to free fall. So the fast chain will have little less time taken for the falling compared to free fall. But then as the number of blocks increases, you see that the time taken approximately almost the same approaches to free fall time. And then interesting thing is, when you find the delta V over V for each collision in the block, the higher number of blocks in the chain system, each block contributes less delta V. This is the average. And to explain this, we have to look at the change in the angle of the block first. So when a block collides, the block above it will have a different angle because of the pulling of the string. So this is the angle change of the upper block due to the collision of the lower block. And the lower block angle is collide at a different angle, they will produce a different delta theta, meaning the change in angle. And this is the graph I showed you before, delta V over V compared to the angle of collision. And we see that these two are the same. And this is fit our model, meaning the more delta V you produce, the more change in angle you produce on the upper block. And since the higher up the block is, the less mass you need to pull. That means the more angle it will change. The red one is the one higher above, and the blue one is the one in the below chain. So when you collide and the block, the lower chain collide, you need to pull more mass compared to the one upper. So it will have less effect on the overall chain. And then we can find a phenomenon here, the slow chain. Here it produces a negative chain angle, but then this is produce a positive, and this is positive and this is 0. This one I haven't explained yet. This upper one, when this collide, the chain angle for the second one. But then the bottom one, when this collide, change in the third one. Okay? And this we can draw a graph because it's quite hard to describe. So for example, this is all 30 degrees and this is 45. When 45 degree collides, it produces a negative for the next one, so 30 turn to 25. But it produces a positive for the third one, so 30 turn to 35. And the 25 collides again and turn this 35 to 45, and this are 30 again. So this system repeats itself, and we call this system the slow chain system. So when it starts, it repeats until it ends, until the whole chain ends. And so this angle, the collision at this angle will produce very little delta V. So we call this the slow chain. So look at these things. There is this block collides at high angle, and then you can see the second block turn flat. The turn has this angle when it collides with the floor. So it produces very little delta V. As you see, the third block doesn't accelerate much. So if we assume there are infinite blocks in the same system, sooner or later, due to probability, you will produce a slow chain. And when once you produce, the system will act like a free-falling system, meaning it won't have much delta V compared to free fall. And then the only delta V you will get is the delta V before the slow chain starts or at the end of the slow chain where the collision is the final collision. And then slow loops might not produce in a system with low angle, meaning at low angle there is not enough delta theta to change the angle collision large enough to produce a slow chain. So that's why we say the longer the chain, less effective is the chain. Wow. For our conclusion, delta V over V is a function of this. And then it's a function of theta, meaning it's not a function of V. You can find any delta V over V by giving me a theta. This is you can use this as the model estimate. It's not actual physics, but it's the model estimate what is delta V over V. And then if you have delta V over V, you can find each final velocity of each collision. And then you can use this again and again and again to find the final velocity. The same, you can use this formula to find the angle change, meaning you can find the angle of the collision before the collision, and then you can use this formula to compute the final velocity of the system. But then I did not do it, it's complicated. You can do it again and again and again, but then it's simple like that. And then they are directly proportional to time, meaning the higher up you are in the blocks, the chain system, the more delta theta or the more delta V you produce, because you have to pull less mass on top of it. And then for effective fast chain, you have to have a shorter string, and the angle of the fast chain should be dynamic. What do you mean by dynamic? Because we know that the higher angle you have about 20, you have a much higher delta V. But then if you have too high, then you get a slow chain. You do not want slow chain. So what we do is we put the high angle at the last block, the lowest block, and the higher block we put an angle about 10. So the lower block will collide and change the angle of the higher block. And then, if you design it well enough, the angle of each block just before collision will be 20 degrees. Because the block below it will change its angle of collision, and then the angle will be just enough that it will be 20 degrees. So it will produce the maximum delta V for each. And this is our report. Thank you very much.
Good. Well, each team has 2 minutes to prepare later short questions. Later, each team has 4 minutes to raise some short questions. Only short questions. Okay. Well, time is up. We will take turn to ask short questions. The first will be Team C to Team A and B. From Team C first, you raise short questions to A and B.
等一下 A 跟 B 好，接 A 跟 B。
And then later will be Team B ask questions and then Team A.
你们丢你的麦克风。哎呀。
Okay, let's start the clock.
我需要问题。
Okay, we should start the clock.
Okay, for team A and B, first question, I would like to know the variable used in experiment. I mean, what length to what length, what angle to what angle. Can you show me your variables in experiment?
You mean what?
Like from what length to what length do you use in the experiment? What change you use?
What change?
Yeah, all of them, all the experiments.
Change parameters.
Not the parameters. I want to see how do you change the parameters. For example, you change number n from 1 to 3 or 5, the height from 1 cm to 5 cm maybe. Show me this data. Can you show me?
Okay.
How do you change the parameters?
Oh yeah, like the you say like this part. If we change the length of the this is change the length, and if we change the theta, we just because we use a hot melt gun. So if we want to change the theta, we just use.
You need to do it again.
Yeah.
Yes, I understand.
You understand? Yeah. Okay. Something. And then if we change the number, you can say we just, but it will keep the different lengths of the whole chain. So we just, if we consider its acceleration, we just consider the same length, form. So we just don't consider the another one.
Is that all?
No. And we change the distance between the two holes. We can find that we use the red line to describe it. We can find that. This we change.
Can you explain to me? Is there any change?
Yeah,
Just slight change.
The hole. We just make the hole and change the distance between the two holes.
Okay. So the longer the distance, the
number don't change. The number will.
No, I mean the distance between holes.
Yeah.
Is it longer? Is better?
Yeah.
Okay. Is it all?
Yeah.
Okay. Thank you.
About block number n, we use the way to first we use the way to knock, but and then we. You mean how to change the parameters?
You change the number of n, right?
Yes.
Do you change the distance between blocks?
Yes, listen to me. That's the first parameters, block number n.
I mean when you change the number of blocks, do you change the distance between each block when you increase the number of blocks?
No, I just changed the block number n, and then we change the theta, angle theta.
What is the distance between block when you change the number of
Here,
n?
red belongs A. I can show
when
you
you change the number of block
picture.
only.
Here.
What is the check block?
A is block here.
What is the distance?
Yes, that is
how many cm? Centimeter.
Centimeter.
How many centimeter? What is the length of the block? What is the length of the
here about there 5 centimeter.
In one picture I see your block is about this small, right?
You mean the block length?
One of the video you showed us.
Block length?
Yes, the block length.
That
Yes.
is maybe 5
How
or
long is
10
the block?
centimeters.
5 centimeter.
Pre-experiment.
Yeah. How long is it? 5 centimeters?
About 10 or 15 centimeters.
Can you show me the picture again?
That video? You mean?
Yes.
This?
Yes, can you play it? How long is this? How long is
About
this block?
10 or 15 centimeters.
10 or 15. So what is the
I don't
diameter of
remember
the block?
clearly. I just want to show you the report.
I know. What is the diameter of the block?
Okay, you know it's
What's the diameter of this block?
diameter.
How diameter of the block? If this is 10 or 15 centimeter long,
Oh, yes.
then the diameter is about 5.
No, it's no more than 1 centimeter.
Then
Okay,
how long
time
is this
is
block?
up.
10 or
Time
15.
is up. Okay, now
Thank you.
next turn is Team B. You will raise short questions to both C and A.
Okay. Thank you for team A and team C, and I have some questions to ask you. The first to team A, does the chain accelerate no matter what the theta is, even 0?
Oh, yes, I will show you the condition.
Yeah, I just want to
Doesn't include 0, the range.
You just
We can talk it later. We have
okay.
detailed
You have to the tail angle change.
What?
You have changed the tail angle.
Tail turn.
Mean angle.
Yes,
Your
yes,
shape
oh,
angle.
yes,
Okay.
yes.
And then I want to ask a question about the do you explain do you want I need you explain why it will be faster. Just use your theory to explain why it will be faster.
Energy transmits from lower to upper blocks. You mean this?
No, I just want you explain. You use your theory
Yes,
in
my theory.
simple way. Yeah.
It's just energy collide, and the energy will transmit from lower to upper blocks, and upper blocks will speed up. But lower blocks do not.
And you use the thread zero. You use the thread for zero to free fall.
Free fall? You mean how to define fast?
Sorry. I will have a discussion with you later. And I want to ask, do you consider the block shape? Yeah, I just see the problem mentioned it is blocks and
Yes,
not
we
the
didn't consider
cylinders.
We didn't consider the
You
cylinder.
just use the cylinders
Cylinder,
and
yes.
don't consider the
We don't.
blocks. So
We
I
just
just suggest
change
you.
its long
Yeah,
slot
so I
shape.
just suggest, and I have some questions to Tim. Say, I'm very agree with your theta's analysis, but I think you have some. Do you have other parameters considered? Do you have considered other parameters like the length of the block or other parameters? Do you have
Do you
considered?
mean the length within the string?
Yeah.
The length of string?
Yeah, you consider.
Yes.
How many parameters you consider? I want to.
Okay, there is the angle
Angle.
for each angle,
Yeah.
and then the angle collision.
Angle.
Okay, the length of string, I do only 2 of them, the longer one, shorter one, and the more longer.
Yeah.
Only 3. Okay, and then the number of blocks,
Number of.
okay, number of blocks,
Yeah.
and the initial velocity, portion, and I think that's it.
Okay, and my friend, I want to ask a question. Do you have some zero to describe the faster? Use some zero we can have to describe its motion, to describe its faster. Do you have some zero to?
How do I know it's faster?
Yeah.
Okay,
No. I mean, do you use your zero to describe its motion? So that you use describe to describe.
No. First of all, I know that the angle of collision will produce different velocity because it's rotating motion. And then the formula is there to just prove it. But then first I know the concept that at different angle it produces a different torque because the collision, the velocity due to the natural normal force. The normal force will produce different rotation moment, different torque. Then we know that the different torque, different normal angle, the angle and the normal force will produce different torque. Okay.
And I have a question ask the team A and team C. I want to ask if I say your pictures, I see your images, if the thread is not strange, how it will change your motion? It
Long length.
yes, it is not straight. It's straight. Sorry.
Oh yes.
If your thread is not straight, it will how to influence your motion?
Okay, time is
we
up.
start today.
Okay, I will
Now,
discuss.
Team A, you have 4 minutes. Ask short questions to both of the.
First, I want to ask Team B. I want to make sure the definition of your speed up ratio.
Speed up ratio. Okay.
Please show me that PowerPoint.
Where?
Definition about this.
Ratio is like this formula.
What does V2 means?
V2 means after the collision, the above blocks velocity.
And I want to Could you please repeat your conclusion about the parameter n?
A number?
Yes.
Yeah. If we check, we get the bigger number and we get the smaller acceleration effect. Yeah. And our lambda is also the zero complete.
And we have the different definition about fast. And at page 29 or 13, 29 or 13, about your experiment.
Experiment?
Yes, I want to.
You mean this?
Yes, I want to. I want to know the lines represent for. There's two lines, right?
Oh yeah.
Two lines,
Yeah.
the red and the black.
Oh yeah.
And what does it represent for? Represent for? What does it mean?
This is velocity over 210.
Velocity and more specific?
Oh yeah. This line, maybe
Yes.
mid one.
Yes.
Yeah, it just means the velocity over 2 is times change.
It's a delta v or what does it mean? Just the
Just velocity.
Just the velocity?
Yeah. We can say it's vertical axis. We can say it. So it's just velocity.
Okay. And I mentioned you have there is a letter E. What does it
Larger
represent
E.
for?
Oh yeah,
Letter
it's
E.
not
A small letter E.
small letter.
就是小写。
Okay. I just mentioned restoration factor. It's between two blocks restoration. Because it's collision between two blocks. It's not just have a collision with ground and the block. It's
So
collision.
is relevant to the material or relevant to what? The E is a constant.
Restoration factor. Restoration factor.
So it's relevant to the material, right?
Material.
Yeah. And I have mentioned you have mentioned many parameters, about 7 parameters. So do they all influence your result? Influence the motion?
I have mentioned it in our experiment. I just choose some important and relevant.
Okay, thank you. Thank you. About team C.
Yes.
And I want to make sure. Could you please repeat your definition about delta V? Delta V, what does its definition?
Okay, basically,
Just definition. You can tell me directly.
the definition of delta V is delta V equal to V final minus V initial. V final as in the final velocity of the second block, and V initial is the initial velocity of the second block. If the second block meaning the block above the one colliding.
So the fast speed is meaning for what?
What?
Last speed you
The-
have mentioned.
Okay, if this block is colliding, at the moment it collides, this is the initial velocity. This is the initial velocity, and then after it collides, this velocity change is a delta V, and then after the change you have the V final.
Okay, I want to know what parameters do you consider in your theory? Parameter. What parameter?
Theta, length, mainly theta, but then length,
Okay, we can discuss it later.
Thank you.
Thank you.
Okay, time is up. Now 2 minutes preparation for a later 12 minutes discussion. Okay, time is up. So now we have 12 minutes for mutual discussions. Anyone can start.
So I would like to start by saying the simple thing, discussing the simple thing. What parameters will affect the fast chain? What is the best fast chain? You can put what angle, what length, whatever.
Best fast chain.
Yes, for the best fast chain.
Okay, you just lady first.
Yeah, we are gentlemen. Yes.
Yeah, we are gentlemen.
In theoretical, we can make a better, the best fast chain, because in my theory there is, I consider 5 parameters, and
I mean, what kind of length, shorter, longer, what type of angle?
yes, 5 parameters, and there are 4 parameters is indirect proportion to the speed, and 1 that is the angle theta is in inverse proportion to the speed. So in theoretical we can make a best fast chain, but my theory there is a range about theta, and we can't give a so clear answer.
You cannot give a clear answer. Can you tell me if the number of blocks is constant at 10 blocks in chain, okay, 10 blocks, what shorter length of string or longer length of string is better? Is it, for us it's shorter, right? Yeah, is it? Do you do the experiment for the length of string between blocks?
Do the experiment and the parameter?
Yes.
Yes, I changed.
So is it shorter better or the longer better?
Just change the TV set between blocks.
Is it shorter or longer better? Which is better? Does it shorter but longer?
It's longer. The thread length A
It's
is
longer.
and the fast chain will be faster.
Okay, you want to
Because
discuss?
the definition of fast between we 3 team is different. You should know. Fast is different. We define and they define and you define.
What's your definition of fast?
That is the fast
The
speed.
final speed of the last
The
block.
delta V. That is the delta V. Delta V.
Can we say you define the fast again? You're defining of the fast.
It's quite confusing with trees.
Yeah. We think this.
Okay. Here, final speed. That is the speed at the moment just before the last block of fast chain that collide with the table.
Yes, that's right. You say the velocity is delta velocity.
Delta V, yes.
You just define this to the fast.
Yes.
Yes. I have a question. I think our define is in some way similar. You know what I mean? Because I just define it is a ratio. If it be fast, so we need the way fast chain and reduce the way free chain. The delta way is bigger. If you want to be fast, so we need this bigger. Okay.
It's greater than 0, it will be bigger.
If you want to, if in your define of the fast, if it's fast, so you need the delta way be bigger.
No, it's greater than 0, it will be faster.
Greater than 0. Oh, okay. Yes, I say you just be. But this is not your define. You mean the delta is bigger and the fast and the faster?
But
Yeah.
The delta V final is greater than 0 and it will faster than the free chain and it's fast.
Yeah. But how fast? How fast? You just use this delta way to describe how fast. You can this delta way describe how fast?
Yes.
Yeah. You mean how fast? Yes. The delta V get bigger and the fast get faster. Can I just?
Yes, you can.
Yeah. So that I use the lambda, the V2 and V0's ratio.
Yes.
So if I need the lambda get bigger, I need the delta V get bigger.
Yes, similar.
Yeah. So I think we have some difference in our experiment. So I want to discuss later,
Okay.
and I want to ask his questions first. Can I ask? Oh yes, thank you. I think the best parameters is theta because we have our experiment. We use 20 degrees tilt angle. Yeah. We will have. Oh yeah. I say. Oh yeah. Okay. I say we have the same conclusion. And I think the distance between two holes, I think it will be bigger. It's closer to the length. Yeah. I think the hole is closer to the length, and so that it will be faster.
Yeah. Actually, you don't have to do experiment for that because we know torque is force times distance. So if the distance between hole is longer, of course the torque.
Yeah, my friend. But you
That's very much better.
ignore you ignore some parameters.
Yeah.
Because if we can according to the theory to have a simple project for this conclusion. But why we need to do this experiment? Because we make the hole I can show it in the background. Okay. Because we get the block and make a hole in it. We just in a straight way to get the hole. We not this way, not the horizontal way to not the vertical way to get the hole. So we need to investigate if the hole's direction will influence our zero predict, so that we can have this predict. So say that our experiment, our zero in this time don't have mistake. Yeah, you know me?
Yes.
Oh yes, thank you. Very thank you.
We did not do that because we need to change the angle between the block constantly from 0 to 45. So we did not do that experiment. Yes. That's all. No. I want to ask. I'm sorry. Do you actually know what happens between the block? You know the initial velocity, the initial angle. You know the final velocity and angle. But do you know what is actually happened inside the block?
Inside of
Like the first one, the second one,
You
the
mean
fourth.
energy loss?
Yes. Do you actually know the interaction? Do you
Yes,
do you
in
only
our
say?
fraction, we considered.
I know, but then can you actually show me a value for each interaction? For example, the
value in each
the
direction.
velocity for each block after each collision. Can you
So,
show me?
so in your theory, you consider that each block, every collision, right? Every time of collision.
Yes.
So how do you control your parameters? You know
What?
what I mean?
No.
That is because when you, so this is the way you consider the parameter n. Because in your theory, you talk about every collision and every block, each time
Yes.
of collision. So how, this is what you talk about,
Yes.
the block number n.
Yes.
And so how do you control other parameters?
For example, this.
The upper blocks, right? The upper blocks, how do you consider it?
After a collision, I have a final velocity, and using the final velocity as the initial velocity, I recalculate it. So I
You
know.
use the way of iteration?
Yes.
Yes.
No, not iteration. It's we find the velocity, and then for each time we calculate again to each
The
block, each
whole block
collision.
number n is constant? Is a constant? Or you just change it?
No.
Well, the whole block number.
Okay, for example, there's a
n.
10 block system. I calculate the velocity of the second block after the first collision, and then the second collision I calculated and plot and
So
fit.
the whole block number is
Of course
a
it's
constant.
constant.
It's 10, right?
No,
You didn't change it.
yeah,
You didn't, right?
no. For that part, the single collision, I just find the value of velocity. But then I actually did the experiment. Can you change one? I see there's a. I change the value of n here. Different number of blocks in the system will cause different time taken for the block to fall. And then if we find the delta V or V for each system, we find that it's less effective when the number of blocks is high. Is this what you think?
So
This is the changing of
this
number
is
n.
one of your parameters you considered. Right.
The parameters
You
itself
have
are
considered the
independent.
parameter block number n, right?
Yes.
And the other parameter, I mean the other parameters. So that is the before the question for the formal question. That is.
Sorry, we are out of time. Do you have any questions?
Oh, yeah.
It should take a lot of time.
Oh, yeah. I think I have a question. If you consider the collision is incomplete inelastic collision, incomplete inelastic collision.
No.
Yeah. I say you just mentioned it. You have
I
assumption.
will show you the appendix.
Yeah, completely inelastic. Yeah, but you just consider the elastic conclusion. Yeah.
There is a value E there.
Do you change the restoration factor? Yeah, hook factor. The hook factor.
Okay. No.
Yeah.
Because
No. Sorry. I mentioned wrong. Yeah, it's just a restoration factor.
oh, okay. You talk about the length of string. Okay.
If how do you change it? So yeah, how do you change the? Do we change the E?
No. I don't change E. The E is there to make sure the model works. This model doesn't actually prove the law. There's no law in this model, but then it's just to use to estimate. So I do not need to use all sorts of Newton law to complete. But then,
But
okay.
I have a very important thing to tell you. The E you just mentioned the blocks with ground or the block between blocks. You mean I say your theory just mean between the E between the block and ground?
Yes.
Yeah. I say you just don't mention
Yes,
the E.
that's a correction.
But
Okay.
I think the collision is between two blocks. Because the first time is the last block have a collision with the ground, and then the two blocks have a collision. It's just not have a collision with the ground. So I think there must something wrong. So I have a suggestion. Just check.
The value E is different for each position in the block. So this is just for the first one, for the ground. If you're talking about higher block, the value E will change. Yes. It won't be a constant, but then it is the model to find the velocity of each block in the system.
Okay. And I have another question.
I will answer about your question.
Okay.
This is similar to the K, similar to the E.
Okay.
It's a constant K, right?
And if the thread
Okay,
is not a thread,
time's up. Okay. Now we have 3 minutes to prepare for 2 minutes conclusion. Again, the conclusion will be given in the order of C, B, S. Okay, thumbs up. Now, let's start from Team C for 2-minute conclusion.
Okay, first of all, I would like to say that their explanation is not adequate. They have the formula for the initial condition, for example, the theta, the initial, the length, whatever. They have all the parameters there, but then they do not explain the inner working. For example, how does the theta change in the block within collision, the velocity change, the length change, and these all things, they do not explain it well enough. And I think it's a pity because they only have a formula to explain what is before and after, but not in between. And in terms of conclusion, in terms of what we find, Team A and us, we have a bit different, namely the length of the string. We find that the shorter length of string, the faster, the better fast chain is. And in B, we have similar conclusion. But then, they do not have the inner working explained in detail, especially the change in the collision effect due to change in theta. For example, how does the different theta angle collision change the delta theta or change delta V. And they do not, because of this, they cannot explain like dynamic fast chain. They cannot explain slow chain system. They cannot use this inner working to design a better fast chain. So I think it's a pity also. And that's all. Thank you.
Now, Team B.
Okay, the first sounds Team A and Team C will have some suggestion and some discussing to me, and it's my player. And then let's have our conclusion. The first, I think, we just mentioned the conclusion occurred between blocks is not only occur between the block and the surface. And the second conclusion is completely is not completely in elastic. It's just in elastic collision. It's not considered completely in elastic collision. And then the third we need to more discussing on the tail angle, like the Team C mentioned. And the fourth, the thread is low. If the thread is not stretch, we all just not mention this. I think it's just have something wrong because the thread, if the thread is not stretched, it will also influence the motion. And then let's have our conclusion. Yeah, we have reduced to our conclusion. We just first explain why the faster chain will be faster, and then the second we just investigate the number of sticks. the length of the stick, the distance between two balls, and the chance tail angle, and then we can get the same conclusion with team C. I think it's my play. Yeah. And then I have some in the end I have some conclusion for the other parameters. We consider other parameters. Why we just not mention it? Because it's difficult to control the variable. So we can just change this parameter and don't change another parameter. So we just don't mention in our conclusion. Oh, thank you.
Team A.
First is the advantage of Team B. They have clear experimental videos and detailed theory, consider many parameters such as the distance between two holes or anything else, and they combine simulation with experiment. And next is the disadvantage. I think they didn't consider also. They didn't consider the block shape, and their theory and experiments is not fitting very well, like page 27. And I think they didn't explain clearly why this chain is faster on Earth, and they didn't give a clear meaning of the meaning. And the advantage of Team C, they have considered many details like the clearing on each block, every clearing, and they bring a new model to explain this experiment. And the disadvantage, I think, is they didn't define the last velocity, right? And the theory of angle and experiments is not fitting very well. And problem to ask us compare with the free fall, not slow chain. And they didn't mention the whole process, and the parameters are few. I think is limited. And our summaries, our theory, we talked about a general connector. First, to learn about the interaction of connector, and then to analyze a special connector, that is fast chain. And here we have qualitative analysis on two views, dynamics and energy, and we also have qualitative analysis with the iteration method. And with experiments, we made some reasonable correction. And here is our conclusion. Block number N, third length A, initial height H, block length L is in direct proportion, while theta angle is in inverse proportion. And thank you. That's all.
Thank you. We have 5 minutes for questions from jury members.
So I have one question for team A and one question for team C. So first, the question to team A. So in your analysis or for your results, you mentioned that you made some correction for the A, and later you in your formula, so you will have a parameter X. So,
yes.
Yeah. Can you explain what the first? Can you give us the value of the X after you fit? So you do the fitting of the value of X. So which fits your data, and then
show the value. It's like it's relevant to the material itself.
Yes. Okay. Then just show one data, and which the new theory fits your data. The data.
Yes, but we didn't show on the PPT
here, for
the
example,
X.
this one. Yes. And
we didn't
the
show.
number. Then can you give the value of the X?
It's a constant. Is the range is 0 to 1, and the exact number we didn't wrote.
So can you repeat again the meaning of the X? So the physics of the X. What does it mean?
It's the delta X means energy loss, and the X is total energy. So X is a constant. It's their equation like this, their relationship.
So the question to Team C. So in your analysis, you are talking about delta V over V.
Yes.
So could you tell us again the V, the V? So which is the value of the V, the velocity you use? At the last moment of the top stick, the last velocity of the top stick at the last moment, or
Okay.
or which one?
This is quite lengthy, so I didn't explain it. In
Very
experiment,
short. In short and clear.
Okay.
I need short and
in
clear.
experiment, we track the motion of the second block
Second block.
before and after, and from the motion before, we can
Yeah, okay.
find a formula.
Please stop. So then, which V do you use in the second block at the last moment?
No. The second block, the motion of the second block, we can use it to calculate or estimate how would the motion of second block move if it did not collide. So like free fall. You understand? Like the motion
Yeah,
of block
I know,
if it
but-
continues.
Yeah, but which value you use? I mean,
So,
even then.
At each time, there is a free fall velocity, and then this is the observed one. We take the difference between them as a delta V, and then we find the average as a delta V. So it's actually the free fall, and the actual observed one.
Yeah, but again, you still don't tell us that which value of the V you use.
At every moment. No, the value of V is at every moment. There will be a lot of delta V final for the collision one, and there's a lot of free fall one. And then you take the difference between all of them, and we average it out as delta V. So actually, it's at every moment.
I'm not asking delta V. I'm asking the V.
Yes, the V is the velocity of the free fall motion. The free fall motion is we calculate it, estimate it from the motion before the collision. So we can use an equation, and then we differentiate it, and we get the velocity equation.
Okay, and then addition to that, and then you have this trend that's the delta V over V. At some point, they will below zero. They will be minus. So,
Yes.
and then is in that regime does the chain move slower than free fall? Or?
No. What happened is the second block above it will move slower.
That is enough. I just wanted to know
Yes.
if
The
in that
second block
regime
will move
if they are slower or
Yes,
faster.
but then the second block
But
will
so
have.
it's enough. I say it's enough.
No.
Thank you.
Sorry, thank you.
So, yes, I know, but that is the answer I want to know. I don't need explanation.
That's no answer.
If you wish to explain, we can discuss after the fight. But that was what I wanted to know. Thank you.
More questions from?
Thank you.
Okay, I just want to ask Team C.
Yes.
You see the angle between the sticks is different. This different angle regards a different velocity.
Yes, different change velocity.
So you just tell us when this angle is not equal this angle, so the velocity will reduce.
Can you repeat?
This is the charge, this angle and this angle.
Yes.
When the two angles is not equal,
Okay.
now the velocity will be reduced.
When we do this graph, we assume that each block, the increasing velocity in each block is independent of each other, meaning this angle and this angle is independent. Why? Because we know that the string between the block is loose. So if this collide, this angle doesn't.
You think the energy is lost?
Yes, of course, energy is lost. There is the value E there in the formula, the model, and E is actually the energy loss, the momentum loss, the velocity loss. It's actually that.
Okay, and I have one question for all of you. I think that you all think that your model fits your experimental results well, but I don't see a number showing how different they are. What are the discrepancies between your model and your experimental results from tonight?
The biggest difference, I think,
Discrepancy. A number. Right. No? Okay. You have a number to show how different or how good your model fits your experiment.
Oh, yeah.
So what is the number?
Look, I don't have this number.
Okay, MC?
We do not have a model for the system, but then we
You
have
don't
a
have a
formula.
model?
We have a formula to estimate.
So you don't have a model?
We have an
Okay, then
estimate.
you don't have to answer this question?
Yes.
Okay.
So we do not have it.
Thank you. Okay. Now, all juries, please conclude the results. Ready? So now the score for Team A. Start with the mic. 8, 8, 7, 8. And the score for Team B. Again, 7, 8, 8, 9.
Thank you.
And then for Team C. 7, 7, 6, 7. Any comments? Okay, so maybe I should give one comment because all of you didn't answer my question. The discrepancy between the model and your experimental result is the fitting. You use your model to fit your experimental result, and you calculate your differences. That's called the discrepancy.
I just want to say, it's too difficult to have because you need to each time you need to have.
That means you're not using a good model.
Yeah. You are good. I'm agree with you. Thank you.
I have one short comment. So in this topic about fast chain, so the topic want us to compare, so to see if really faster than a free fall. So in Team B's definition, in Team C's definition. So I think one thing you have to tell us is that is the chain really faster than free fall? So you have the value, but in one of your results you have the value, the velocity value, but you didn't tell us which value, how fast is the free fall? Is it really faster? And again, the Team C you also didn't tell us if really faster. So that is why I asked. And then you study a lot of stuff, and you tell us how everything how faster, and that is the delta V over V. But you have to stress one thing: in all your study, every fast chain is really faster than free fall. That is also important. You have to stress this, and then okay, how will the effect? What's the difference, and so on. Thank you.
Okay, thank you very much. We conclude this session.